a good point to get started with. Thank you all for being here today. It's good to be with you all, and I just thought this would be a nice way to gather at the end of the 2024 year. So I'm Madeline Wimmer. I'm a University of Minnesota educator in the Department of Fruit Production. I'm a regional extension educator. I do cover statewide. So if anyone was familiar with Annie Claude, she was in this role before I had joined here in July 2023. I give kind of a variety of presentations between presentations that will talk about how to have a good mindset, whereas others are going to be a little bit more directional or more based on grower recommendations. And today, the talk that I'm going to be giving to you all, spotted wing Drosophila, is a pest that many of us are familiar with. But there's been a lot of research and different innovations that have kind of been developing, along with just research about the pest biology. So I thought that I would give this presentation. It was originally created for the Prairie Fruit Growers Association in Manitoba. So this is a cold climate issue as far north as Manitoba. Um, and just from the registration, you can see here that if you are, we have a mixed group of folks who are confident or less confident when it comes to managing or understanding management with spotted wing Drosophila. So if you're feeling like you're more on the unconfident side, you're in company, and that's all right. Today's talk, I'm going to be starting off with a rundown about spotted wing Drosophila biology along with its life cycle. This may be a review for a lot of you. However, I hope that there's some take homes or a couple of things that can help really connect the biology with the management aspect of everything. And then we'll dive into what it means to really start to craft an integrated pest management mindset when it comes to managing spotted wing Drosophila. And then we'll kind of run through what that might look like, what options are already available, what innovations are kind of coming out. And I'm really hoping that there will be enough time for some discussion. So if you're around at the end, we'll be ending at 1 today. And if you're around at the end, please join us for some discussion. Some housekeeping, if you can keep yourself muted during the presentation, that would be helpful. And during discussion, you're welcome to type your questions in the chat. We'll talk about them after the presentation. And when we're discussing, you can, open up your camera if you want to talk and do it that way. Please feel welcome. As I'm giving this presentation, I have a lot to learn as well from growers and your experience. So your input is important and valued. Just some quick acknowledgements here. So thank you to the University of Minnesota Rogers Lab, along with the Torque Lab for the research they've done with spotted wing Drosophila, along with those parties that have supported that research, as well as just nationwide, the efforts that have been made to understanding this pest and how we can really start to manage it in a way where it feels a little bit more balanced. As we'll dive into this, we'll be talking about, hold on here. So spotted wing Drosophila, because it's an invasive species, it's technically a fruit fly, or in some parts of the world, they may refer to this as a vinegar fly. But it's been in the US since 2008, and it's really been more prominent and introduced to Minnesota since 2012. But it is native to parts of East Asia. Hold on. And that's understanding that it's an invasive pest is really an important thing to understand. Japanese beetles would be another example of an invasive insect pest. But oftentimes when we're dealing with a pest that is newly introduced, it's going to be a little bit chaotic, right? They have a big advantage, and that's why they've been able to be problematic in their way. They don't have natural enemies built up. They don't necessarily have predators and parasitoids built up. So hopefully we'll get to a good place with management, but we'll continue on talking more about the biology here. And most of you are probably familiar with how to identify spotted wing Drosophila. It really takes like a 10x lens to see up close a lot of the adults. They can look similar to other fruit flies. But of course, the adult males have this identification of the spots on their wings, which leads to their name. And then if you had a little bit more magnification, you would be able to zoom in and see that the females have this serrated ovipositor, which is advantageous to them. It allows them to be able to lay eggs in ripening fruits, whereas most fruit flies need very soft fruits to be able to lay their eggs in. So that ovipositor is that part of the spotted-winged Drosophila where it's going to be able to access the fruit and lay eggs. And additionally, the eggs do have breathing tubes, which also gives them an advantage. A few more biology notes. It's important to note that as a fruit fly, spotted-winged Drosophilas have a very thin cuticle, which means that they don't do very well in dry conditions. That's something that's really helpful to understand. Especially when you start to think about fluctuations in seasonality, thinking about what you saw with perhaps that very dry spell towards the end of the growing season this past year, and what you saw when it came to spotted wing populations. They're very small, right? 2 to 3 millimeters. They go through complete metamorphosis, which means that similar to like a butterfly or a ladybug, they're going to have an egg phase, larval, instar phases. They will pupate and then they'll emerge as adults. And females can lay up to 200 to 400 eggs in a lifetime. And that contributes to why they can cause so many issues. Something that was newer for me is recognizing that newly emerged adult females are going to be attracted to something different than what females that are looking to lay eggs are attracted to. So these newly emerging females are going to be looking for soft, rotten fruits, that vinegar smell, the yeasty smells, all of that. But by the time a female fly wants to lay eggs, that's not what it's actually attracted to. It might be somewhat attracted to that, but it's really looking for all these different volatile compounds that are related to these intact fresh fruits. So when does the fruit become susceptible? Fruits really become susceptible when they become softer and when the sugars start to build up. And at that same time, you're going to have a reduction in acids. And this happens to correlate with the first color of the fruit, which if you're producing grapes, sometimes that's referred to as veraison. So I'm referring to this chart on the right side of your screen here. And you can see that bar there where it says first color veraison, and then that pink area where it says susceptibility to spotted-winged Drosophila, and that's when it's really taking off. Which fruits are most susceptible? There's a wide range of susceptibility that is mostly based on how thick a fruit's skin is. This is why wine grapes, which have much thicker skins, are way less susceptible to spotted wing unless they're damaged than a table grape that typically has thinner skins. And of course, this kind of keeps going on a spectrum until you get to the point where you are working with a crop like raspberry that is so soft skin that someone like Mary Rogers from the University of Minnesota would call spotted wing candy. Jumping into the life cycle here, you may have seen this chart on your left side of your screen where you're seeing that life cycle that I talked about, right? Complete metamorphosis from egg to adult. And that is happening during the growing season. So the life cycle length can vary. We'll touch base on that in a moment. But it's important to recognize that we are now starting to study more about the potential for a winter morph to survive in northern regions. And again, so this one on the left, right, you're going to be having that go on when reproduction is happening in the summertime during the growing season. But there's a little bit of question about what could be happening during the dormant season. So you might be wondering, does spotted-winged Drosophila overwinter in Minnesota? And based off of based off of research that has been done on what I would refer to as the summer morph, which is what I introduced to you, that thin cuticle fly that you're going to be trapping in the summertime, they're very susceptible to, or they have a very low threshold when it comes to cold temperatures and survival. So is that morphology surviving through the wintertime? No, it's not. However, there has been a lot of research done mostly through Oregon State University that looks at Spywing Drosophila's winter morph. So Spywing Drosophila does go through diapause, meaning it's kind of like an insect hibernation where it's going to actually change in its biology, where it's going to be a little bit darker. It's going to have a thicker cuticle, which allows it to not dry out as much. It's not going to have as much issues with low humidity, which is typical of winter temperatures. And it's not going to do a lot. It's mostly feeding on detritus or like dying materials and fungus that is helping to decompose those materials. And it's going to be seeking shelter. So it's not eating the same things during the winter time as the summertime. And yet there's still this question, right? As you can see here, 23 degrees Fahrenheit, that's not our most extreme winter temperatures in Minnesota. So how would that be possible? And you could imagine that most are not going to be surviving, but if there's any sort of semi-shelter that's available, hay or barns that are a little bit sheltered, there could be little spots perhaps where Spywing Drosophila could hang out. So this is from the University of Minnesota website, just saying that most spywing Drosophila of what we think is going to be migrating in. However, there is some evidence for this overwintering, but there would be the need for shelter. And as Spywing Drosophila moves in, there's kind of this question of would it be blowing along the jet streams like thrips? And Bill Hutchinson, who's done some research with the University of Minnesota, thinks that or he, based on his research, had seen that that probably is not the case. They're really coming in more at the level of the shrubs. However, it's possible just there's a lot of activity. There's other ways for spotted wing to slowly start to come in. And we'll discuss more about this, but you could ask yourself if it is coming in, if it's not overwintering, how do you slow down its entrance to your crop? And I think it's important for us to also consider the overwintering potential because as we start to anticipate shorter or warmer winters in northern areas, that leads to the possibility for just earlier growing seasons starting to accumulate that heat a little bit earlier in the growing season, as well as longer growing season. So there's more potential for that to become an issue in the future. And I think it's still worth talking about. And once spotted wing is here, once we're in the growing season, how many generations are you really dealing with every growing season in Minnesota? And I thought I'd throw this up there because it's kind of hard to see a circular chart when it's saying 20 to 30 days as an adult, 12 to 72 hours, right? And all of that variation as to how long it takes for an egg to hatch or for a larva to start to pupate or for something that is pupating to break out as an adult. That's going to be based on environmental conditions where there's going to be an optimal temperature for all of that. And so if you wanted to think about it, if there are these great optimal conditions, it can go through its life cycle in as short as 10 days, could be even just a little bit shorter than that. And the slowest is going to take about 25 days, could be a little bit longer than that, where these adults are still going to be lasting for 20 to 30 days. And so in Minnesota, we've kind of established that it seems to be showing up between June and July. And for those who track growing degree days, this lines up with about 755 growing degree days from the start of that growing season. And this chart here is from SROC, so that's our research center out of Waseca. And there's kind of this question of if you thought spotted wing was early this year, was it early this year? Well, if we look at the growing degree day chart here, we can see that that 755, which might be a little higher. I might be misestimating that slightly, but it's still lining up where it came in about mid-June. So that still lines up with that anticipated growing degree day baseline. And if you have not tracked growing degree days with trapping, this might be something helpful so that rather than anticipating it by a month, you're actually anticipating it by the calculated growing degree days, which could be a little bit more accurate. Spotted wing Drosophila likes warmth. It doesn't like a lot of heat, but it likes warmth. It likes shade. It likes humidity. That's its cozy spot. And so it's very active within temperatures between about 71 and 82 degrees. However, it may cease activity above 86 degrees. And where do you find shade? Where do you find that high humidity environment? We'll talk about that in a moment. But I do want to mention that, especially for those who have close forest approximations with their growing operations, that there's always this option for daily migrations to happen. So oftentimes spotted wing might come out in the morning, or when those temperatures become optimal, it may do some egg laying and feeding at that time, and it might retreat during the hottest parts of the day, whether it's retreating, in a very close by forested area or some other shelter. And then once that heat backs off, it may come back into the field. So that daily migration is something that has been observed with spotted wing. And then where is it looking to hang out when it's near, whether it's blueberry bushes or it can affect haskap, right? Raspberries. It's going to be trying to find those shadier parts of your canopy. And it wants just because that's going to be giving it that optimal condition. There's not going to be a lot of wind when there's shade, right? Shade is going to affect airflow as well as sunlight and heat. So we'll mention, as you can think about how this might affect management, having that open canopy is going to increase airflow, decrease humidity, increase the sunlight coming through, making a less favorable environment. So after talking about all of that, you can imagine that spotted wing Drosophila is very tricky to manage. So a lot of this comes from the fact that the eggs are laid under the fruit, so they're protected. They can pupate within the fruit. The pupae can also drop out of the fruit, so that kind of gives that variability of, even if you're harvesting fruit all the time, if it's dropping out, it's still going to be present. Still good practice to be harvesting any fruits that might be infected. And just that the populations are fluctuating from year to year, and you've got that fast life cycle, and it's a small pest. And the concern is that because something like that can be such a high pressure and get out of hand so quickly, this can lead to a bit of panic and a bit of perhaps an abandonment of good management practices. A lot of berry crops without spotted wing may have very little pressure for diseases and pests. So all of a sudden you throw something like this into the mix, it makes things really challenging as a grower. And if, for example, the solution ends up being spraying more insecticide applications more frequently, this becomes concerning, of course, because there's always going to be effects with pollinators and natural enemies, but there's also the chance for resistance to build up. And then we'll dive into management here. So it's just so important, part of what my message is for growers is just to start to think about what it means to manage a pest. What's the opposite of that reaction and panic that happens when we're caught off guard? The opposite of that is really being able to plan. What is your knowledge around a pest? Do you have scouting practices? Do you know how to ID the pest? Do you have the right equipment? Do you have perhaps a dissecting scope or even just simply a jeweler's lens available to help you identify? And then knowing how you're going to make decisions and implement those decisions and options, taking records and reassessing your situation, all based off of your values, that can all lead to successful management. So that's why we're diving into all of this. And I'll mention that a lot of the most recent research came out of this OREI grant, which was nationwide and had about 14 different labs working on projects very directly to organic management practices and taking in mind, thinking about how economically viable all of these practices are. So the hope is that in the future, or I guess from the past year, we migrate from this place of kind of, a little bit of confusion or inconsistency, concerns about UPIC, concerns about losses, all of that. And then we dump it into all the research and everything that we can learn and understand, and hopefully we can make more plans and help growers make better plans as we continue to kind of understand these things more, and that will lead to more positive outcomes. So we'll start here discussing a little bit about scouting and trapping with spotted wing. I'm sure a lot of folks are also familiar with homemade traps like these. There are Sentry and perhaps some other companies do make commercial lures that are going to be a little bit more specific, and they're going to be dry, which means that you're not actually, you don't have to deal with that liquid and trying to pull things out or filter things. So that it's good to know that that's an option. However, the homemade trap formulation that the UW had researched and recommends is really a simple mixture of vinegar, dry yeast, table sugar to stimulate the dry yeast, water, and then dish soap, which helps to break the surface tension so that when something's there, it's not just hanging on the surface, it drops down. And this, of course, is this going to be a solution for trapping females that are trying to lay eggs? Probably not. Based on what we talked about with what spotted wing adult females are attracted to if they're newly emerged versus if they're looking to lay eggs, we know that they're not really looking for that rotting fruit. So this is more of a way to detect. And it's so important to detect spotted wing because once it's there, it's already starting. So that's still important. So again, some other considerations is just to make sure that if you are using the liquid traps to be changing them out at perhaps every week or when after you check them. Maybe you do it a little bit more frequently if you know that you're kind of close to that 755 growing degree day area. And then just making sure that you know how to identify spotted wing compared to other fruit flies because this will attract other fruit flies as well. And then when it comes to monitoring it in the fruit, by the time it's in the fruit, we're in a different phase of management because we know that it's already starting all of what it's been doing. There is the option for doing a salt flotation method. And this is where you're going to collect a number of fruit samples based on there's a different guidelines out there of how to do these protocols. But this is you'll be collecting fruit, placing in a bag. You're not going to be grinding it or like blending it because that would be ruining the larvae. And that salt, once the fruit is slightly mushed, you're adding salt water to a bag or container. That allows for the larvae to hopefully float up. They're a little bit more buoyant when they're intact as well. Another reason to not mush it up too much. And then there are ways to either, you can look, simply through a light, but if you have a way to sift them out and to be able to look at some of these larvae under a dissecting scope, that's what's going to be probably your best method. And if you haven't looked at like pricing for dissecting scopes for a while, I actually haven't, but there are options. If this was something that like a decade ago, it was really expensive. It's still good to check on pricing, and it's still helpful to have these kinds of things around just to be able to identify other diseases as well. So that's an option just to be, if you were a little late to checking your traps and you're not sure where you're at when it comes to what's in your fruit, that's helpful. Jumping into management here, when should management begin? That might be your first question. And we'll dive into this, but perimeter management may be your first step. So if you know that they're migrating in, um, we'll talk more about it, but that's going to be an option. But it's important to recognize that there's not an economic threshold. You don't start to manage spotted wing when you have five fruits with larvae in them per 30 fruits. There's no threshold like that, and it is pretty conservative. So management recommendations are really going to start when you see spotted wing in a trap. That doesn't, and again, this could be chemical management, cultural management. There's a lot of different options when it comes to IPM. And the whole idea to this talk and the system and where I hope that spotted wing Drosophila management will head to is it's going to be a system, right? There's not one silver bullet, but there's going to be a few things that can help reduce the need to spray. And it's more hopefully going to be something where it's might involve more planning, but once it's there, it's set up, it's hopefully adding a little bit more balance to your operation. So cultural management is going to be a sort of a catch-all category that has to do a lot with decision making. Where are you growing? Which cultivars did you choose to grow? How are you managing the crop? How are you harvesting the crop? How are you managing the floor of your operation? And even something like this, how are we talking to customers, perhaps. Perhaps there's a way to have some public relations aspect to the way that we think about spiraling Drosophila to encourage people to find quality fruit, right? There's never anything wrong with just being like, yeah, here's how to pick the best fruit without mentioning that there might be the ones that aren't so good, might have this in it or that. So thinking about, yeah, something like that in regards to your customers, if you're doing a U-pick operation, for example, could be really helpful. Jumping into that perimeter conversation. So there's been research that's been done. David Tork at the University of Minnesota this past year just started jumping in to look at specifically honeysuckle, but there's a number of different plants that some of which are invasive that can actually be a host to spotted wing Drosophila that may be in perimeter forests that are perimetering your fruit operation. And yeah, if they're invasive, again, this just gives you another reason to go out and remove some of those plants. And my coworker next door to me who focuses on invasive species plants would also be very happy to know that everyone is doing that. So it's something that maybe, you need a little more inspiration to do anyway. So that's something that can be very helpful. Is to think about that perimeter management in that way. Is there anything that's hosting spotted wing and kind of giving it that midpoint between wherever it was outside of your place to your crop itself? So we'll look a little bit here at what David found in 2024. He had given me some data to share with all of you. And this is just a map showing, I should back up here. So David's lab really was looking at honeysuckle species. And there's a number of different honeysuckle species, one of which is haskap or honeyberries. And haskap is not invasive. It's been studied with the MDA here. And they believe that has low potential to be an invasive species. However, there's a number of honeysuckle that are invasive, and then there are some that are not invasive, but they're still around. So this is a huge list. I'm less of a non-food horticulturalist, but it's helpful to see that they surveyed all of this. And then on this next page here, you can see on the one on the left, that's where they surveyed. On the one on the map on the right here, how big those dots are is showing you how much spotted wing infection or that they saw within the fruit. So those dark bubbles here, those are the haskabs. And you can see that there's not as many locations with the dark, and not all of the ones with the dark are that there's variability is what I'm trying to say. So that's important to point out. Here are some box plots from David Tork. And if you're not familiar with box plots, pay attention to the lines going through the boxes. That's where the average is, whereas the extremes are going to be at the ends there. And then the boxes are kind of like in the middle of those extremes, the ends of the boxes. When you see n equals 17, n equals 13, that's saying how many plants were sampled to come up with this data. And for each of those plants that was sampled, up to 30 berries was picked. So there's variability, and you can kind of think about, as this is preliminary or not preliminary research, but this is 1 year of research. So there's going to be some variability. But what you can see here is that dark blue box there, that's going to be the haskap. And haskap has larger berries, so it kind of makes sense. But when you see some of these others, you might be like, well, 0.5 in one fruit, or, one larvae every 2 fruit, that doesn't seem like a lot. But when you look at a lot of honeysuckle plants, they have so many berries on them that could equate to quite a bit of spotted wing being hosted. So we'll move away from David's research there, and we'll kind of come back into our management techniques. So coming back into the cultural management, there's this question of, can you grow a crop that could escape? And there was, I guess I already spoiled it, but there was some speculation that during some years where spotted wing shows up kind of late, maybe crops like summer-bearing raspberries and honeyberries could escape it. Perhaps, but we know that that's not a consistent thing to put your bet on. I'm going to pass that one. And then cultivar susceptibility or varietal susceptibility. Are there any varieties that are more or less susceptible than to spotted wing? And as I mentioned, that fruit skin thickness is that potential for there to be resistance. There isn't a lot that's known about any varieties of raspberries or blueberries that are resistant. As I had already mentioned, table grapes are are going to be more susceptible because they have thinner skins than wine grapes are. And then I've heard, from one grower that, they've noticed, for example, that blue gold blueberries just don't seem to have issues, but that's anecdotal. That's nothing that's really been researched. But if you've seen that yourself, with any variety and you want to kind of weigh in on that and grow more of it because of that, it might be a good thing to observe for yourself and to invest in. And as I had already sort of alluded to before, how you manage your canopies, how well you prune, if you are training, if you're doing any trellising with raspberries, anything that opens up that canopy, decreases humidity, and allows for sunlight to come in is really going to be helpful. And that has been researched as well. Floor management. How do you manage your floor? And I feel like this is kind of, there's always going, there's not going to be one right solution here either. If you have, vegetation in, for example, you might be able to create an environment for more natural predators to be around to eat pupae on the ground. But you're going to have higher humidity. If you have weed fabric down, that's, especially if it's black, it's going to be probably creating more heat than what is helpful for the pupae that hit the ground. That's going to be helpful in its own way, but you're not going to have the vegetation there. So again, similar to ecology, we're raising plants in our own orchard or in our own fruit production setting, and kind of like pushing things around. And thinking of it that way can be helpful rather than trying to be like, this is going to be the one helpful thing. That's going to be the one helpful thing. Really think about what's going to work well for you and your operation. Again, water management, what could lead to high moisture levels and humidity on the ground if there's standing water, if you're doing overhead irrigation versus drip irrigation, if you don't have great drainage on your site in general, and there's just more likelihood that you're going to have standing water after rain events, especially heavy rain events and frequent rain events that we saw this year, that can be a bit of an issue as well to consider. And then, of course, sanitation and thinking about harvest frequency, which is something that we've also researched here at the University of Minnesota, is really helpful. If you know, especially if you know that you have spotted wing and it has started to get into the fruit, frequent harvest is what's going to help you reduce the amount of pupae and adults that that continue to perpetuate the issue of their life cycle. And you don't want to just throw fruit on the ground, but you want to contain it. And either, you can put it in bags and bake it in the sun or throw it in the trash, whatever you want to do to kind of get it off of your property in a way where it's sealed and contained. So harvesting fruits frequently can be helpful, even if they're not fruits that you think have spotted wing in them. And then I guess one moment here. So I was going to mention, I'll mention it now, but there'll be a slide in a moment that basically says cool your fruit down as soon as possible. So moving on, research has been done with exclusion netting in a number of different research institutions. Cornell has worked on it. University of Minnesota has worked on it. But that's been more promising and again, it's going to work for some farms more than others, but that physical exclusion is really there in a way where it's keeping spotted wing out because you're using netting that has small enough mesh where spotted wing cannot get in. Some keys to making this successful, as you can notice in this picture I have on the screen, there's a door and that door has a double entrance. So you don't want to be bringing spotted wing in. If you were to bring spotted wing in and it was netted, then you're kind of in a different place with your management at that point. So designing any type of netting that you're planning to use in a way where you have an ability to have sort of a midpoint when you enter can be really helpful. And there's a number of different designs. Again, just making sure that that it's going to work for your land and your operation. This may not work for larger operations. It just kind of depends. So there's that slide that I wanted to show you all. But yeah, cool your fruit immediately. 32 to 33 degrees is what's optimal for that. And you can encourage, again, without having to mention spotted wing, you can encourage your customers to do the same, just because that's what's going to, you know, preserve the fruit well, and they can take it out a few minutes before eating to let the aromas kind of come back out of the fruits if that's important to you. Chemical management here. So before doing any, before thinking about selection and before actually applying any chemicals, it's really helpful to ask yourself, have you caught spotted wing? Has it shown up in a trap? And then is your crop susceptible? Has it started to change color? And do you need to protect pollinators as well as predator insects? Is that important to you? As well as where and when is your fruit being marketed? Are there certain time, paying attention to pre-harvest intervals? All of that is going to be really important. And I'll point out, if you want to, again, this will be recorded, so you're welcome to, see this video again once it's up on YouTube, or I can send out kind of a list of links at the end here. But this is going to link you to an Excel sheet, which is basically a worksheet for growers to kind of calculate your returns versus your management practices. And this is on our Veg Edge website. And Bill Hutchinson, I believe Gigi DiGiacomo came up with this. So if this is something you're not familiar with, this is helpful to know about. And again, thinking about chemical management, resistance is just a little bit more important here as compared to other pests that have slower life cycles because of that rapid generation that's happening there, as well as just drosophilid flies are a little bit more susceptible to building resistance. What is available for Minnesotans? So here are a list of different insecticides. And what's important when it comes to understanding preventing resistance is to be rotating those classes of insecticides if you have that option. So you can start to see, if these generations are so fast, how can you rotate and have an effective program that can be so challenging? And trust here, which is the active ingredient is spinosad, that is one of the organic approved insecticides that has really been researched a lot by that OREI group that I mentioned earlier. The University of Minnesota has a couple of different rotations that we have recommended for conventional growers. This would be rotating organophosphates with pyrethroids and either some sort of spinosad or spinotorum. I'm not your chemical person when it comes to pronouncing those, so apologize if I mispronounce that. And then for organic growers, there's a little bit more limitations, right? So, and this is what really stimulated that research effort, is that it's not practical on an economic level to be spraying something like Entrust as frequently as what might be needed. So alternative management practices, or at least combining these alternative management practices and integrating them into your plan, is going to be really helpful. And just thinking again in general, like, so rotating is important, spraying at the right time is important, but also coming back to that canopy management part. You'll hear me talk a lot about canopy management as a horticulturalist who has a great background. I'm very much so a canopy management proponent. But when you trellis and when you prune well, you're not only just opening up the canopy to good airflow and sunlight, you're also allowing more effective spray penetration to fruits that are inside the canopy, which is really helpful, especially knowing that that's where spotted likes to hang out. And I think it's really cool. I'm just mentioning this as kind of a cool thing that's sort of been popping up more recently. There is a company that has been working with Cornell that has created a product that actually increases pesticide efficiency, which is, again, that was sort of, that was not a sustainability approach that I had been exposed to before I had spoken with this group. So this would mean that we'd be using less product overall. And I had somebody ask me who isn't here today, but is hoping to catch the recording about botanical repellents. So here, this is the paper that came out most recently from the Rogers Lab, looking at efficacy and economic viability of organic control methods for spotted wing. And they were looking at with day neutral strawberries. And they did some exclusion netting, they did some frequent harvesting and looking at that. And then they looked at eco-troll. And I think during their first year, they thought it was somewhat promising. Their data, once they did all the analysis, kind of came out saying that it wasn't super promising. However, this is one study, and what what can contribute to it being less effective is just recognizing that these are volatile compounds. So they're really not going to necessarily last quite as long. And it's really meant to be a repellent, right? So it's not going to kill spotted wing Drosophila. And the question is, well, is this really practical? Maybe this works as something to do as a first step when you've noticed that there's spotted wing in the trap or around, that time period where you anticipate it, just as that first step to kind of, warn things off, but not necessarily this would not necessarily be a catch-all management practice. And then these are, again, some really cool innovations that are coming out, thinking about attract and kill methods, which means anytime you have something that's attract and kill, it's either going to be attracting and then giving it an insecticide, or it's going to be attracting and then trapping it in some sort of way with or without an insecticide. So you have these attracticidal spheres that have been researched. These were done with Entrust, as well as Kaizo. And the effectiveness does seem to go down with large population sizes, which makes sense. And then you have to kind of ask yourself, well, how many of these would you need per acre for your operation? And resistance is still possible if something is making contact with an insecticide and flying away with it. There's still that chance for it for resistance to build in populations versus traps where something is physically trapped in and not allowed to escape. So more research, I think, will be coming out with this type of mechanism. Um, and then moving on here, this is also something that's kind of exciting for perimeter management. So this is an epoxy-based substance that has an attractant in it, but it also has an insecticide in it. And it is referred to as hook for spotted wing Drosophila because spotted wing Drosophila gets hooked to it. But it is based on the SPLAT technology. So specialized pheromone and lure application technology is what SPLAT is. And it can be applied in a number of different ways. I haven't really looked into kind of like the environmental considerations for this, but it was a part of the OREI research effort. So you could imagine that if you are anticipating spotted wing moving through, I believe this product is available now and is something that could be trialed if this was something that you were interested in. I'm really excited for this product, Decoy, which is just very new. I believe they're at a place where they're kind of giving samples to certain researchers who might want to trial it out and do research trials. But look forward to more about this within the future. This is a food grade gum that also has attractants in it, but it doesn't have insecticide. It's a physical mechanism where spotted wing it's attracted to it. It tries to lay eggs in it. So we're attracting those females that want to lay eggs. And there hasn't been, I believe it's mostly one research group that's looked at this gum, but from their research, they found that there was more preference to the gum than fruits in general. And again, this is going to be similar to thinking about the tracticidal spheres. How frequent do you need this in your acreage? How many do you need total? And this gum needs to be moisturized in order for it to be effective. So that's why the mechanism that this research group focused on was hooking it up to irrigation in a way where it was constantly wetting it throughout the day. And that allows it to stay active and attractive to spotted wing. So there's some different aspects of it. It's very interesting. And so again, this would be something that might take time to set up, but then you're not as concerned later. And Yeah, whether this is a practice that replaces insecticide or not, I'm not sure, but I think it's really cool to start looking forward to some of these things. And we'll go through this biological management section pretty quickly because I want to give us time for discussion here. But biocontrol is kind of a wide range of different categories that you could look at. So you've already got natural predators available, but we could be looking at something like nematode soil applications, which is what they're studying in Michigan State University right now. We have parasitoids, which lay eggs into the pest, and those eggs eventually hatch and kill the pest, or you have predators that are just eating the pest. So there's a lot of things that fall into the category of biocontrol. And there's three different ways to kind of think about how you're going to have biocontrol happen on your operation. So one is conservation, which I sum up as avoid killing what's already there. Two, augmentation, encourage what is already there by creating conducive habitats. And then three is introducing or importing something that isn't already there. And what is the efficacy that biocontrol can help with, depending on your environment, whether it's an enclosed environment or open field, depending on your winters and all these different factors. Some data suggests that you can, kind of capture 50 to 90, 15 to 90% control with different biocontrol techniques. So what already eats spotted wing Drosophila? Crickets, spiders, ants, earwigs, several beetle species are out there. Again, that's where it's like, well, if you make nice habitats on the ground, if you have cover crops, things like that, that's great. But then you kind of have to balance with that whole aspect of humidity and whether you have low-hanging branches that could also be contributing to all of that. When you're importing biocontrols, this is when we're releasing biocontrols, you really want to you want to be selecting something that has a similar origin to spotted wing Drosophila. It's not going to be sensitive to the insecticides that it might be exposed to, and it has good biocontrol specificity. This means that it targets spotted wing Drosophila, but doesn't target other types of Drosophilads. So the higher the specificity, the more promising it is that it's going to just target the pests at hand and not start to get other parts of our ecology out of balance. Parasitoid wasps, as I mentioned, parasitoids lay their eggs inside of either a larvae or a pupae, and then at the point where the parasitoid wasp egg is ready to hatch, it hatches out and kills its host. There are two wasps that have really been looked at. I mean, there's been multiple wasps, but of those wasps, these two have been important to pay attention to, and that's Ganaspis brasiliensis, which is very specific to spotted wing and is sometimes recovered in different parts of the US. But there have been some adventive or like pop-up populations of Leptolina japonica as well. So that's also exciting. We've seen this with Japanese beetles as well. We've seen fungi that have been parasitizing it along with certain flies. And so it's always exciting when we can get our ecology in balance by having some natural enemies that are specific to that pest. So here are those two. They are, I apologize if I said pupil, they are larval parasitoids, whereas these pupil ones were researched, but the focus seems to be more on these other two at this time. Augmentoriums are something that have been studied, and this is the practice of raising and trying to like increase the populations of parasitoids. How do you do this? A 1 millimeter mesh goes on top of like a tent or some sort of structure that is completely enclosed, and so you actually raise spotted wing, a small population inside of that tent. That screen allows for the wasps to get in and out, but spotted wing stays trapped in there. However, after I talked to Mary Rogers a little bit about this, she had mentioned that there is a little potential for a bottleneck effect to happen, which is basically just concerns that that the parasitoids may not be getting enough genetic diversity when they are breeding. So that's not as helpful for stabilizing populations. And finally, look forward to this in the future with the University of Minnesota. We're hoping to partner with Agrigene, which is an innovative company who have been working on using more innovative technology to release sterile males as a method for spotted Drosophila management. And there have been sterile releases happening before. Most times that was done by inducing it through radiation. And for you, this may or may not fall into your value system, but CRISPR technology has allowed for people to create sterile males in a way where there is no radiation process that is used in the production. And these sterile males will mate with females, and the females will feel like they were mated with, so they'll go around and try to lay eggs, and they will create little wounds that are then sealed up. Not big deal, but they're not laying any eggs around. And the potential for something like this to escape in the environment is similar to thinking about a sterile watermelon, which we eat sterile watermelons all the time. They're seedless watermelons, and we're never really worried about them escaping because there's no ability for those seeds to be viable. This is the same where you would have to be purchasing sterile males in, and then yeah, it would have to happen every year because there's not going to be a sterile male population growing or being raised at that time. What are the take homes from today's talk? Knowing the biology about spotted wing can really help inform us when it comes to the management. Understanding, is it coming in? Is it overwintering? Is it not overwintering? What are those favorable environments? All of that. There's multiple approaches for spotted wing Drosophila management, especially when within the context of integrated pest management. Kind of threw all those in there as like a little, don't read that. It's just a picture of all the things I went through. And research is ongoing and promising. So if you're not familiar with the fruit and vegetable newsletter that we send out, this goes out weekly during the growing season and is out every other week during the off season. Again, I'm Madeline Wimmer. This is my email here if you ever want to reach out. I have a small Instagram channel there. And then I just have a couple other notes here. If you are interested in partnering with David Tork, he is still looking for growers to work with. This is his email. Along with, this is a national survey that's being done right now, that if you would like to fill that out, all of that really communicates what's going on. Every time you're able to fill out surveys about pests and diseases, that really just helps support the cause, raise funding for research, all of that. So thank you all for being here with this talk. I'm going to open this up for discussion, and I'm here with Lauren, who's kind of here to facilitate as well. So with that, I'm going to stop sharing, but remember this will be on YouTube, as well as if anybody just wants resources, feel free to reach out.
Madeline, there are 3 in the chat. Did you want me to read them off, or did you just want to look at
Sure.
them and okay. Let's see here. The first one, do you have opinions about ereth erythritol spray applications? Sorry, I'm probably not
Oh no,
pronouncing that correctly.
let me see here. Oh, erythritol. Yeah, and that's, I mean, that erythritol is a sugar substitute. That is not something that I have heard of as being used. And I would have to kind of look into that a little bit, Lily, but I could definitely, if you want to follow up with me by email, we can chat about that for sure. And then there's a question about floor management. So Terry says, do you know of any research looking at soil health and pest populations of spotted Drosophila on a farm scale? We generally accept better health reduction in pest pressures, but curious if that can be expressed as explicitly for spotted Drosophila. So how can soil health affect spotted Drosophila populations? And the one thing that I had mentioned previously is just that if you have poor drainage, that can lead to humidity and those nice conditions that allows for spotted wing to really hang out in lower canopies. Beyond that, though, I think that's a really great question, and I know Terry personally, so I'm looking forward to talking more with her about that. But that's a great question and something that could be looked into. Um, Along with some, Jan had asked about using surround clay, and I'm not sure about that. Again, that would be kind of whether that would be effective or not would be about how much is spywing attracted to fruit crops based on just visuals versus other volatile compounds coming from the fruit. So surround were to be there in a way where it was also kind of lulling down some of those volatile compounds that attracts the females that are looking to lay fruit, then perhaps. And then, yeah, again, how does that work out in a U-pick situation? Things like that. I don't have an answer for that, but that's a great question, Jan. Oh yes, yeah, and the hummingbirds. So Courtney was asking about the research on hummingbirds eating spine-winged Drosophila. And is anyone trying this in the Midwest? I had one other grower who was asking me about this before I hopped on here, and I haven't actually looked into the hummingbird research, but that's really cool. And I think, yeah, again, if there's just how many can they eat in a day? How many hummingbirds would you need? Again, like we're doing this from an ecological approach. So is there any harm to bringing hummingbirds on your property? Is there anything that they could get exposed to where they may not be doing as well? We wouldn't want to be bringing hummingbirds on if, if there was something other practice that harmed them. So that would just be one consideration that I would think about. Okay, cool. And then Lily mentioned that the erythritol research is coming out of Jana Lee's lab from USDA. That's awesome. I'm happy to hear that. There's a plethora of things that have been looked at, so that's great. And then Bill says, how is spine-winged Drosophila managed in their native area as compared to the tools described here? And so if you were to think about spine-winged Drosophila in its native area, the pressure for spine-winged Drosophila is going to be much lower just because it's in its native environment. It has those parasitoid wasps there already. It has predators that have been co-evolving with it for however long. So that's kind of what I can say about that. I haven't dived into completely with management strategies within any of those regions. But that is something that's a great point to bring up for sure. So with that, I guess we just have a couple minutes here. If I am considering perhaps having kind of like another group during the growing season to check in with folks. If that's helpful, then I will definitely offer that, and maybe we can have more discussion at that time. My talks can get a little long and winded, so I apologize for that. But yeah, we're about 2 minutes at the end here. And I'll also mention that when we do end this talk, you will have a window pop up that is asking you to complete a survey with about 5 questions. So again, if you have the time and the ability to do that, it's so appreciated. But I'm just so happy that you all are here today. I figured it'd be just nice to kind of do this as an end of the year event. So thank you all. All right. And with that, I guess, oh, yeah, we'll just close it there. Oh, okay. We're going to close it here. So thanks, everybody. Have a great rest of your year.